equation that we're used to. Okay, so the question is, what isn't a polynomial function? Would this be a polynomial function? No. Because he has a root. He's a root equation. Would this be a polynomial function? No, because he has a negative. He makes him a rational function. How about this guy? Is he a polynomial function? No, he's not. Go ahead and answer him. No. Absolute value. So in this first example, if it says which are polynomials, this guy is not. He has a root in him. This guy would be a polynomial function. This guy is not because he's an absolute function. And this guy would be a polynomial function. Okay, so then if we want to pick the pieces out of a polynomial function, this is the degree. This, whatever is in front of x, so 1 would be there, is the leading coefficient. This guy is the constant, and the constant of the equation is also the y-intercept, so that's where it's crossing on the y-axis. So we can pick these out of these polynomials. So it's important that the leading coefficient is always with the highest degree. So it might not be always the first in the equation. So if I have this guy is the leading coefficient. This guy is the degree because he's the highest power in the equation. So in B, if we wanted to say what the leading coefficient was, the leading coefficient is 3. The degree is 4. The constant, since there isn't one here without an x, we would say the constant is equal to 0. And we can do the same for D. So in D, this is the biggest, so the leading coefficient is 2. The degree is 3. And the constant is at the end. Is negative 1. Okay, this is on page 109 in your textbook. It's very helpful. It lays out all different types of polynomial functions, what they look like. So this one being a constant, it means it doesn't have a degree. So it doesn't have an x with it. This one is linear. We're familiar with those because it creates a slope, so it has a degree of 1. This is quadratic. It always has the highest degree of 2. Okay. Cubic, highest degree of 3. And then quadratic, highest degree is 4. And then they say cryptic, the highest degree of 5. Okay, the degrees tell us how many times in the picture it changes direction. Okay, so if you look at this, if it has a degree of 1, it's going from down to up. It's changing direction 1 time. The degree in this one is 2, so it means it changes direction twice. So down and then up. Okay? If we have a 3 one, it changes direction 1, 2, 3 times. For a 4 power, 1, 2, 3, 4 times. So on. Okay, so if we remember correctly, this is quadrant 1, this is quadrant 2, quadrant 3, and quadrant 4. So the leading coefficient and the degree give us information on where the picture starts, in which quadrant, and where it will end. So this is important to write down. If you have a negative to quadrant 1. Okay. The last two, put them over here. If I have a positive leading coefficient and even power, so it looks something like this, even power, positive leading coefficient, it goes from quadrant 2 to 1. So if you're positive, you're even smiling. So it would look like this. And our last one, if you're not positive, if you're negative and even power, okay, so we use the information we just talked about for example 2 on page 110. So we want to know if it's even or odd, which quadrants it's in, x-intercepts, the number of possible x-intercepts. So on this screen, when I was talking about how many times it changes direction, if you have a degree of 1, you have a number of possible x-intercepts of 1. If you have a degree of 2, then the possible x-intercepts is 2. If you have a degree of 3, the number of possible x-intercepts is up to 3. Okay, so that's what they're asking for here. Then we state whether it has a max or min. The only ones that have a max are these ones, have a maximum, and these ones have a minimum. Okay, and then the y-intercept. So looking at A, if we had to match the pictures, we would look, it is odd, it's even power and negative, so it's even and negative. So that should be quadrant, makes a frowny face, quadrant 3. Quadrant 4. So it has a even degree and an odd leading, an even degree and a negative leading coefficient. This is the end behavior, quadrant 3 to quadrant 4. The number of possible x-intercepts, since we have a degree of 4, the possible x-intercepts would be 4. Whether the graph will have a max or min, well, we know that even makes, and with a negative leading coefficient makes a frowny face. So we would have a maximum value. And the y-intercept is always the constant, the guy without the x. So our y-intercept would be -4. So then if we try to match the picture, this guy starts in quadrant 3 and ends in 4. He has a maximum intercepts of, 1, 2, 3, 4. And he's even and negative